Hi everyone. We have the first class for sequence and series that continues to arithmetic progression and geometric progression. And for every topic in mathematics, it is quite important that you understand the language of the topic. That will ease the stress you would further get when trying to go deeper into the topic. So I decided to do the first lesson for just the introduction. Just the introductory part of the topic. These are the terminologies that are commonly used in sequence and series, arithmetic progression, geometric progression. Let us try to understand them. Well, these two are the primary words. Sequence and series. Okay. Now, when we talk about sequence, it's just an ordered list of numbers. An ordered list of numbers. That is just a simple way. For example, let's say we have 3, 5, 7, 9. We can choose to stop here. Or we can simply say 8, 9, 10, 11. We can choose to stop here. Or we can say 4, 9, 14, 19. We can choose to stop here. These are examples of what? Sequence. They are just ordered list of numbers. So when the numbers are added that are listed, when they are added, we have what we call series. 3 plus 5 plus 7 plus 9. 8, 9, 10, 11. 4, 9, 14, 19. So when the numbers are listed in that order or in a specific order, we say a sequence. This one is a sequence of numbers, sequence. But once those numbers that are listed are added, we no longer say what? Sequence. Rather, we say what? We say series. Now, what is the focus of the sequence? Sequence focuses only on what is coming next. For example, 3, 5, 7, 9. What is next? What is next? 8, 9, 10, 11. What is coming next? So that is the focus of sequence. And series, the focus is not what is next, but the focus is what? The total. So basically, when numbers, values are listed in a particular order, we say a sequence. And once those values are added, we now have what we call series. So that is sequence and series. Okay, I think we are done with these two. Let's come to terms. What do we understand by terms? The word term could be defined in a specific topic. Maybe in English they have what we call term. Mathematics, we have term. So even in mathematics, we have term in different cases. But in sequence and series, when we say terms, we mean what is listed. This is a term, this is a term, a term, a term. All these ones are terms. So in other words, when terms are put together, when we list numbers with commas, basically, when numbers are listed like this, those numbers are what we call terms. For example, we can choose to say what? A, B, C, D. So if we use letters to form a sequence, those letters are the terms. We use numbers to form a sequence, those numbers are terms. Whether it is a series or sequence, these are terms. So instead of us saying the first, in fact, like term could be like a general word. So for example, we don't want to say letters are listed, numbers are listed, this is listed. We can just say a sequence of letters, a sequence of numbers. And we don't want to be saying specifically the first letter, second letter, first number, second number. Rather, what do we say? We use the word term. So we can say first term, second term, third term, fourth term. First term, second term, third term, fourth term. And that is it. So we can say 1, 2, 3, 4. We don't want to say four numbers. 1, 2, 3, 4. We want to say four letters. We don't want to say four mangoes, four this. So we can simply say terms. So it's like term is just a general word for what is listed. So four terms. This is the first term, the second term, the third term, the fourth term. We don't want to say the first letter, the second letter. We can just say the first term, second term, third term, and so on. So this is what we mean by term. So it may sound funny or interesting to have a special concern for first term because once numbers are listed, you just have to expect first, second, third. Yeah. But here, the first term and the common difference or common ratio, yeah, they are specific. So the reason I included first term, because we would say, okay, well, once we say first term, it's like we are waiting to come and discuss second term, third term, or the 20th term. No. So we are just particular because these ones, they have special letters that we can use to denote them, to represent them. So first term, as the word implies, first, it is the first one that is among the sequence. Yeah. Among the terms, it is the first one. The reason we call it first term. The first term is 3. The first term is 8. The first term is 4. The first term is A. And this first term, it is accepted to be denoted by A. So in sequence and series, most often we use A to represent first term. Yeah, we use A what to represent first term. Just like I was saying, we don't want to be saying the first number, second number, first letter, second letter. We use a general word, we say term. So likewise, even when A is used to denote first term specifically, but the general symbol for term is T. The general symbol for term is what? Is T. So saying this is the first term, we say T subscript 1. Subscript. Yeah. So normally we just say T sub 1. T sub. Yeah, we have subscript, we have superscript. So T sub 1, this is T sub 2, T sub 3, T sub 4. So this is what? First term, second term, third term, fourth term. So here again, the first term, the second term, the third term, the fourth term. But specifically, the first term is denoted by A. The first term is denoted by A. So in sequence and series, you see A, just know what it is, first term. Yes, T1 is first term, T2 is first term, but uniquely or specifically, A is representing first term. Okay, so that one is done. Now let's come to what we call common difference. Common difference, I want to reserve this one for AP and GP, and also common ratio for these two, AP and GP. There is something again I think I've forgotten. Types of sequence. Types of sequence, types of series. Now, basically, we have two types of sequence. Yeah, we have what we call finite and infinite. We have what we call finite and infinite. Finite and infinite. Yeah. So when we talk about finite, it means the number of terms is known. Like here, we can say 4, 9, 14, 19. Someone asks you how many terms? 1, 2, 3, 4. So we know exactly how many terms are there. So we can say this sequence is a finite sequence. Yes. But the thing is, numbers, generally numbers, no one knows the last number. No one ever lived that knows what the last number. So come to think of it, if no one knows the last number, how do we know that this one is infinite? Well, it's by indicating 1, 2, 3. So once the sequence appears like this, know that it is an infinite sequence. Why is it so called? Because the last number is not known. And don't think that the last term is 90. No. This one signifies that the sequence continues. Continues to where no one knows. So therefore, it's an infinite sequence. Yes. But what if, for example, at some point it appears like this and say 44? Is this a finite or infinite sequence? It is definitely a finite sequence. Why? Because we may not know how many terms are there without checking or without applying the mathematics. But the fact that the last value, the last term is understood, is given, is known, we can say this one is a finite sequence. So sometimes we don't define finite sequence as a sequence where we know how many terms, but basically we can say a finite sequence is one where the last term is known, the last term is given, the last term is understood. So once the last time is not given, it is an infinite sequence. So the same thing applies to what series. If the last term is given, it's a finite series. Otherwise, it's what? An infinite series. Now let's go to what we call nth term. What we call nth term. Yeah. Nth term is called the general term. Nth term is called the general term. Now let's say we have 3, 8, 13, 18, like this. Yes, this is what? First term. First term. And after first term, we have second term. Yes, we have third term. We have fourth term. We have fifth term. We have sixth term. Okay, let me write this. Okay. So as the word implies, general term. Yes. Why this nth term in sequence and series? Okay. Now, when we talk about first, second, third, fourth, we don't have time. The only way we can generalize saying first term, second term, third term is by saying what? General term. So when we say general term, it could be what? First term. It could be second term. It could be any term. But why TH? Because in cardinal or in terms of position, TH dominates. We only have ST ones for one. We only have ND ones, like what? The second, the 22nd, yeah, the 32nd, something like that. And third again, RD is what? Is just like few. ND is few cases, ST, but TH dominates. So if you replace this with N, the reason we have it as what? The nth term. As to meaning what? To represent the general term. And this general term, which is the nth term, is denoted by T sub n, depending the author, depending the textbook. It could also be denoted by U sub n. But the reason why most authors they use T sub n is because T matches with what? Term as compared to U. Yeah. But T subscript n could be what? Nth term. This also nth term. I hope it is clear. This nth term, we have it for AP, we have it for what? For GP. Yeah. If you are talking of what? AP, well, the nth term is A plus n minus 1 multiplied by D. That is the first term, the number of terms, the common difference. So whereas for GP, the nth term is AR to the n minus 1. Yeah, the first term, the common ratio. Here, first term, common difference. First term, common ratio. Number of terms, number of terms. So this is the nth term, the general term for GP. This is the nth term, the general term for what? For GP. Now, what do we call last term? Yeah, what do we call last term? Last term, as the word implies, last. If you have like 2, 7, 12, 17. What sequence is this? This one is what? An infinite sequence. It does not end. The last term is not known. So because there is no last term, we cannot get like last term here. But if it's like this one, what is the last term? The last term is 17. The last term, of course, there is no other way to put it. Last term. I cannot say it is the last number, the last letter, but it is the last one that comes in a sequence. And this last term, the interesting thing is that the last term has the same formula as the nth term, which is a plus n minus 1d. And here again, the last term is a r to the n minus 1. I hope that one again is clear. Okay, now let's go to GP and AP and GP. AP, then GP. Here, the nth term is a plus n minus 1 multiplied by d. The nth term is what? AR to the n minus 1. This one is common difference. This one is common ratio. Yeah, the common ratio is a particular term, let's say T3, divided by the preceding. Remember, we have first term, we have second term, we have third term, we have fourth term. Let's stop here. So common ratio is a particular term divided by the preceding. It is a must, but it has to be the immediate. So this divided by this. If you want, you can say T4, but once you say T4, it has to be over T3. Once you say T19, it has to be T18. And on the other hand, when we talk about the common difference, this one goes like what we say, this minus this. So a specific term minus the preceding term. Yeah. And the only way you can say this sequence is like when we talk about AP and GP, basically, they are unique terms, or they specifically represent the nature of the sequence. Now, let's say we have 4, 7, 10, 13. Ask yourself this question. For you to get the subsequent terms, is it by addition or subtraction? Let us try by subtraction. 4 minus what to give us 7? There is no way we can say 4 minus something to give us 7. But with plus, we can. 4 plus 3 can give us 7. 7 plus 3 can give us 10. 10 plus 3 can give us what? 13. So if you have a constant number, you add or you subtract to get the subsequent terms, that sequence is an AP. Now let's say we have like let's say we have 12, 6, 3. Okay, let's stop here. What did I say? For it to be an AP, there must be a constant number you add or you subtract to get the subsequent. Let us try it here. If there is a number we add or subtract to get the subsequent, what do we add to 12 to get 6? Unless you say negative 6. Okay, that one is understood. But here is a minus sign. 12 minus 6 will give us 6. But can 6 minus 6 give us 3? No. And we need a constant number we perform to get the subsequent terms. So the fact that here by addition or subtraction, we cannot have a constant number, this one is not what? An AP. But this one is an AP. Let's try for multiplication or division. What do we divide by 12 to give us 6? 12 divided by 2 will give us 6. 6 divided by 2, can we get 3? Yes. So there is a constant number you divide to get the subsequent. So if it is done by multiplication or division to get the the subsequent terms. But the number you keep multiplying has to be consistent, or the one you divide has to be consistent before ever the sequence is called a GP. So this one is a GP because there is a constant number we divide or multiply to get the subsequent. Yeah, here is an AP because there is a constant number we add or we subtract to get the subsequent terms. So that's how we differentiate them. Okay. Um, what is again the sum to infinity? Um, basically, for basically the sum to infinity is applied to what? To GP. It doesn't mean that we don't have it here, but there is an advanced aspect of it. So for basic mathematics, we only discuss sum to infinity in GP. Yeah, so the sum to infinity is A divided by 1 minus R. But R has to be less than 1. This is the condition. R has to be less than 1. Of course, you can see here. So this is all I have for the introductory part of sequence and series. Thank you for watching. Don't forget to follow, like, share, and comment. See my next video.